Around about 2 weeks after Guillaume Laforge came out here to do his talk on Groovy, he pinged me and told me of Philippe Mougin, Philippe Mougin, who's doing a language called FScript, which is kind of a small talkish language for automation and scripting on Mac OS X. So it gives me great pleasure today to introduce Philippe from Octo Technology. He is the creator of FScript, of the FScript programming language, sorry. And Ken Ferry is here from the Cocoa Group at Apple, who's a contributor to and daily user of FScript. So with that, take it away, boys.
Good afternoon. Thank you.
Sorry. This talk is going out as an external Google Tech Talk, so hold any Google-specific questions to the end, if you would. Thanks.
So first, thank you, Dick, for setting up this session. And thanks to Guillaume Laforge and Pierre Pezziardi, my colleagues at Octo Technology. Together, we work on things like dynamic languages for enterprise systems. So thank you guys for helping me making this session possible. So today, I'd like to show you 3 cool things related to scripting. First, a scripting and interactive layer for the Mac OS X object system, for Cocoa. Second, what I think is a really terrific object browser. We'll see if you agree. And third, a new high-level programming model whose goal is to free your mind. It's based on the integration of array programming and object-oriented programming. So the Mac OS X object system is derived from Smalltalk. It is based on Objective-C. It is very dynamic and quite powerful. In particular, it provides a dynamically typed system, meta-class system, that is, classes are first-class instances, and flexible and very dynamic runtime. And in the latest and greatest version of Mac OS X, it's now a 64-bit object system, and it has garbage collection. Using this model, Mac OS X provides many object frameworks that implement or give access to the Mac OS X technologies. Most of the applications are developed with this object model and the associated frameworks. This amounts to thousands and thousands of applications. And quite surprisingly, this probably makes it one of the most, if not the most, successful dynamic object system in use today for application development. So let's represent Mac OS X in a very schematic way. We have a Unix system. And on top of it is the Objective-C model and a vast collection of object frameworks. Yet, Objective-C is not an interactive language like Smalltalk, but a compiled one. FScript provides a lightweight scripting and interactive layer on top of this model. With it, you can interactively access the Mac OS X frameworks and your own objects, of course. So it provides you with scripting and interactive access. It is embeddable, that is, you can easily put it in your own application. And it is injectable. It means you can inject it into any Cocoa application dynamically at runtime. This makes it a great tool to explore an application from the inside, manipulate it, debug it, and so on. And it's open source. So FScript provides an object-oriented shell that I'm going to show you. It has various object browsers and inspectors, and it is completely integrated with Mac OS X technologies, such as object persistencies, remote invocation, and so on. Here is a screenshot of a typical FScript session. So you see the object browser here, the object shell here, various inspectors. So what are the main use cases for FScript? So first, it is used by many macOS 10 developers as a development tool, as a complement to Objective-C. It's very useful to explore interactively the macOS 10 frameworks or third-party frameworks. It's very useful for debugging, prototyping, or even writing parts of your applications. Another use case is to employ it as a user-level language. That is to provide it to your users as an interactive domain-specific language, for instance. What you have to do is that you modelize your domain as objects and just let users interact with them using FScript. So it's also useful for automation and application extension. For instance, FScript is used in Colloquy, which is a popular IRC client on Mac. Using FScript, one can write plugins that extend the Colloquy application. Another example is Daylight, a popular business productivity suite on macOS 10. In this case, Daylight makes use of FScript in its report engine, letting people directly type FScript expression to customize the reports. And it's also used for scripting. Another example is Project X, which is a project management application. In this case, FScript is used internally as part of the engine of the soft. The last example here is Event Horizon, a 3D space game. And as you can see here, FScript is used directly here to power the player console, the game console. Now, let me talk a little bit about the FScript language itself, showing you the syntax. So we can, after that, show you the cool stuff and the demo. So first, it's a Smalltalk dialect. It's a pure object language. Everything is an object. Numbers, Boolean are objects. Message sending is a fundamental control structure, and it has closures. And what is important to note is that the FScript object model is the Cocoa object model. It's not a separate object model that we are bridging to the Cocoa object model. It's really using the native Cocoa object model. FScript strings are standard Cocoa strings, arrays are standard arrays, and so on. Here is an example of a method invocation in Java or C++. We invoke the method play on a playlist object. And here is how we do in Objective-C. Syntax is a little bit different. We send the play message to our playlist object. And here we do the same in FScript. As you can see, the expression is the same, except that we do not use brackets around messages. This is basically because FScript is a very simple language, and sending a message is nearly the only thing you can do. So there is no need to have a special syntax to delimit messages. Here we invoke a method with multiple arguments. So as you see, method names in Objective-C and FScript are like sentences with gaps in them. When you send a message, you fill the gaps with the actual values in order to create a meaningful sentence. This way of denoting messages comes from Smalltalk. It's the Smalltalk syntax. And it's a very appreciated feature of Objective-C and Smalltalk and FScript because it lets you have very expressive message sending expression. In this example, we see that, as in Objective-C, messages can be strung together. Expressions are evaluated from left to right. giving us the same semantics. Okay, so it's the same as in Objective-C without the brackets. Unlike Objective-C, FScript supports binary messages. That is, messages whose selectors are composed of non-alphanumeric symbols. In this example, we invoke the greater than method on object 1, passing object 2 as argument. As you see, there is no type declaration in FScript. Everything is an object, and you don't have to explicitly type variables. The assignment syntax uses colon equal instead of just equal, and the instruction separator is a dot, like in English sentences. Again, this is standard Smalltalk syntax. FScript uses the semicolon for a notation called cascade, which lets you send multiple messages to the same receiver sequentially without having to re-specify the receiver each time you send the message. And finally, blocks in FScript are denoted with brackets. They are first-class objects and are full closures. They can have arguments. There is a block with 2 arguments, and local variables. For instance, here is a block that takes 2 arguments, adds them, and returns the results. We can execute it by sending it a value message like this. And the result is, in this case, will be 7. Here is a table that shows other syntax details. As you can see, strings are enclosed in single quotes, and comments are enclosed in double quotes. OK, this is it for the syntax. And now I will show you the first demo, which is the object shell and the Cocoa integration. So let me switch. OK. So this is the FScript shell, the command line interface. And this is not part of FScript normally. It's just a little demo assistant I will use during this talk. So here I can type FScript expression. For instance, adding 2 numbers. OK, here I am invoking the plus method on the object 2. Now, what if I send a message that an object does not understand? Let's say 2, something awful. OK, he says an instance of number does not respond to whatever. Now let's send a message to a string to ask for its class. OK, it returns NSCF string, which is the standard classes that is used on macOS X to implement strings objects. Another example of using the standard macOS X API, let's create a date. OK. Now, let's do some graphic stuff using the standard macOS X API. Again, using Quartz, I can, for instance, draw a circle. Here's how it works. The NS Bezier pass is a standard graphic class in Cocoa. I ask it to instantiate a Bezier pass that represents an oval figure. And here I give a rectangle. And I ask it to stroke itself on the screen. Yeah, it works. OK, I do it again. So it's just standard, using the standard Coco classes, but you are using it interactively instead of having to compile a program, build a project, and so on. Let's see a more complex example with the converter. OK, so let's paste the code here. And I will just execute it before explaining what it does, so we can see the end result. So I execute it. So it opens a little window here, which is a currency converter. I have, for instance, $50 to convert. OK. And the currency converter is kind of the hello world in Coco. All tutorials and guide show how you can build this little application. In general, with Coco, you will build this kind of application using Interface Builder, which is a graphical design tool. But here, since we are looking at the FScript language, we do this programmatically because it's a good example to show. But FScript also integrates completely well and transparently with Interface Builder. So let's see how it works. So first, here, you see that I just instantiate a window, passing in some information for configuring it. Here, I create an FScript block that will compute the actual results. It works by going in the form, taking the value, doing the multiplication, and setting the new value to the resulting text field. Here I configure the form itself. Here I instantiate and configure the button that we see here, the convert button. And you see that I set its target to be my FScript block. Here I instantiate and configure the decorative line. And finally, I put the component inside the window and then the window on the screen using this message. So it shows that you can use directly the standard Coco class or any Objective-C class you have. Now let's see another little demo. We will use the Core Image framework. Core Image is a relatively new framework in macOS 10 that allows for doing optimized image processing, such as deforming images and playing with images. So let's use it from FScript. First, I will load an image that is stored on my hard disk. OK, I put it in a variable named image. OK, and then I can display it by just sending the draw in rect message to the image itself. And OK, it displays. Nice. Now I can, with the Core Image framework, I can apply various filters to manipulate the image. And what is cool is that the filter can be applied one on top of the other. And all of that is translated to optimized code that is executed on the GPU. For instance, I can apply a UAdjust filter like that. I just create a filter object, configure it, and set it to use the image, to apply on the image. And now I can display again the image and see how it looks. OK, the image has been modified. Let's add another filter on top of that. For instance, the edges filter. Again, I just instantiate a filter, configure it, and apply it. And I display the image again. OK, another transformation. Let's say I want to apply a perspective filter. And display the image again. OK, nice. And finally, let's load the original image. And now I will apply a bump filter on it that will create a bump on the image. And instead of just applying it just one time, I will do it in a loop in order to create a nice little animation. So let's do it. Here is the code. So you see here I create the bump filter. I configure it with a radius, a scale. And here is my loop, where I just change the filter each time I pass in the loop. And let's see what it does. OK, so the bump is going through my image. Nice animation. I can experiment with it. This is why it's interesting, because it's interactive. So I can try things. For instance, I can change the radius of my bump. Let's give it a big value and see what it does. OK, the bump is enormous this time, so the animation is different. Now let's see quickly a few other cool features. For instance, let's define a simple block here. So it's our block that adds two numbers. Name it my block. OK, I can call it like that. OK, and I can say to it to provide, for instance, an inspector. So I can edit it in a more easier way. I can test for the syntax. OK, I have undo, redo. I can even execute it. It is asking here for arguments. We will not do that right now. And let's say, for instance, I want to send it to someone or save it for later use. Well, I can use the standard macOS 10 object archiving system. Just send it a save message. OK, and it asks me to choose a file to save it. Let's name it block on my file system. OK, I save it. Now it is in my file system. I can load it again by doing this. I select the object or the object graph I want to load and click Open. OK, it has been loaded. This is using the standard object archiving system, so it works for any object that is able to archive itself. And finally, let me show you, for instance, using the distributed object system with FScript. OK, I will open a second FScript instance, OK, a copy of FScript. Here. OK. And let's say from here, I will publish my block as a distributed object. My block. So I have to give it a public name. Let's say, let's call it test. OK, so it returns a connection object. You can look at it if you are interested. And now let's switch to my other FScript instances. here I use FScript, but it could be any other macOS 10 application using the distributed object system. And now I will define distant block, and I will connect to my block in the distributed object system, like that. Test, connect, OK. So let's see what I have in my variable. OK, I have a proxy for my block. I can send it a message. And it works. So one can make any kind of object into a distributed object. It's fully dynamic. There is no need to generate stubs or any special stuff. So if a macOS 10 application publishes a distributed object, you can connect to it from FScript and play with it just like that. OK, so this was the first part of the demo. I quit this. No, Ken.
Thank you, Philippe. My name is Ken Ferry. I'm in the Cocoa group at Apple. And I'm also a very enthusiastic user of FScript and Evangelist as well, as you can see since I'm here. So I'd like to talk a little bit about some other uses of FScript. So far, Philippe has been showing you sort of the basics of the syntax and the fact that you can use it to just play around sort of in its own world. However, for my purposes, that's not really what I want to be doing with it. I'm a developer of the Cocoa framework, which does not itself have any FScript in it. So exactly what am I using it for? Well, I'm using it as a development tool. It's part of my environment, the same way my editor is, and the same way a debugger like GDB is. But it's quite a bit more pleasant than GDB. And I actually spend more time in FScript than I do in GDB. And it's, like I said, it's the enjoyable time. So I get to give some of the interesting part of the talk. This is probably also the way most people use FScript, though Philippe has given some examples of the other uses as well. So there are two things I'm going to get to talk about. So one of them is the object browser. This is the other UI complement to the interpreter that Philippe has already been showing you. The object browser is used just as much. If he weren't trying to sort of ease you in gradually, I'm sure he would have already been using it in his session. But he was saving it for me, so I'll talk about it. I'm not going to say what it is too much yet. I'm really going to demo it first. But somehow we're visually traversing the object graph at runtime and messing with it. So that's half of what I'm going to talk about. The other half of what we're going to talk about is sort of the basics of exactly how you do use this as a developer tool, how you end up using it with your own applications. And that's really going to come down to using this FScript Anywhere application, which what we're looking at here, by the way, this is the window that comes up when you just first download the FScript package and open it. This is an application developed originally by Nicholas Riley at the University of Illinois at Urbana-Champaign. And it's now maintained by Robert Chin, who's also at Apple. Oops. Sorry. That's where I want to switch over to the demo. So the demonstration is going to be concerned with, one second. Philippe uses a French keyboard, so I unfortunately have to, I'll either be extremely slowed down or I need to switch to an American one. OK, hopefully that will do. So again, let us pretend that we are developers, which is not very hard. But you might have to pretend a little bit harder to pretend that you are, in fact, macOS 10 developers, which some of you may be, some of you may not. But let us say we have an application, and that application is called Sketch. So this is one of the standard examples that ships on macOS 10. It's free with the developer tools, which are also free, so it is entirely free. It's in the box when you just buy the operating system. I think that's pretty cool. It's a relatively large application. It's one of the 2 largest samples that we ship, probably. You see all these files. That's really the only reason I have it here. I'm not going to look at them at all right now. I'm just going to build it and launch it. And it was already built, so it's very fast. So what is Sketch? Well, it's very similar to the old application Mac Draw, if you happen to be familiar with that. You can make these ovals. You can color them. You can make squares if you want. It's oodles of fun, especially if you are 8. So here we have it. OK, here we are. We're developers. This is our application. We would like to use FScript. What are we going to do? Or why do we want to use FScript? Well, all right, so I'm going to come over, and I'm going to hide this for a minute while I go and look at the FScript package as it's downloaded. This is what you see when you first download it. And I'm going to open this FScript Anywhere application. So what do I see? Well, I see a list of applications. These are all of the Cocoa applications which are currently running. And most applications on the system these days are Cocoa. And as we are pretending to be Cocoa developers, so is ours. And our application is in the list, and it's Sketch. We're going to choose to install into Sketch. What this means is it's actually going to dynamically load FScript at runtime into the Sketch process. So it looks exactly the same unless you have very good eyes. You may have noticed that there's an extra menu up there now, FSA. That stands for FScript Anywhere. And the anywhere is to say that it's running in your application space as opposed to in the FScript process itself. We've injected it completely at runtime. Which is pretty cool. So now if I just select that workspace from the menu, I have that exact same interpreter that Philippe has been working with. If I want to type NS application, which is our, forgot to change the keyboard layout apparently. If I say NS application, this is the standard base application class, shared application. I get a singleton instance. And look at the delegate. This is just sending some message to it. Well, I'm getting back some object, which the interesting thing is that this is our object. We're now traversing the runtime graph of our own application, and we can just mess with it. You can do the same kind of thing in GDB if you're patient, but it takes a long time. It's not really good for working at a high level like this. OK, but like I said, so what I'm really going to demonstrate is now the browser. We haven't clicked on this button yet. I'm going to click on that, and we get this object browser. Well, what is this thing? Well, it's let me demonstrate it a little bit before I tell you what it is. So far, all we see is a sys object in this leftmost pane. This is representing a particular object which is present in the workspace of this application. If I type sys over there, that's what it is. And since I haven't given anything else a name, that's why it's the only thing I see. But what we're really going to focus on to begin with is this button over here, which is Select View. So as you are very likely not Cocoa programmers, let me tell you first what a view is, what that refers to. Well, we are a fully object-oriented system. Everything that draws itself on the screen is an object. And NSView is the base class of all objects which draw themselves. So typically, when you look at a window like this, pretty much everything that seems to the user like an independent object, like those buttons in the top, like the scroll bar, like the, well, we'll see about the rest of it. But those are views. And what this is going to do is it's going to let me click on and select in the browser these individual views. So I'm going to click right here on the scroll bar. What do we see? We see something called an NS scroller. I haven't said what this means yet, but it's obviously doing something related. If I go over here and click on this button up here, this zoom button, well, again, it's a little hard to see what's going on, but it says button over here, so I'm getting something related. But now I want to talk about how it relates to our own objects as developers. So I'm going to go click on this canvas object over here, or else I'll click on the shape. However, it happens, and now we're starting to see the true model of our application. These individual objects, it happens, are not implemented as views. There's just one big view here. You see, wherever I click, I'm getting the same object, the same graphic view. That's because there's just one big view here, which is the canvas, and it's drawing itself all of the individual shapes. So we're seeing that detail. That's something that you would not understand if you were not using FScript or if you're not the developer of the application. And now I'm ready to tell you what's actually going on here. So each column is going to represent an object. And at the top it's giving you what the object is. This is the description for it. It's an SKT graphic view, which is the class of the canvas. As we go down, we see some properties of the object. And this is OK, but actually the really interesting stuff is when we get past the properties. What's all this text here? This is all of the methods this object implements. And so it's starting to look, it's fairly similar to a DOM inspector, if any of you are Firefox developers. Web developers. I mean, it's letting you see your object model. It's letting you go through it. But it's a little bit different because so for example, when I click on the scroll view, there's this hierarchical structure where I'm getting to go through and see in each column a different object. However, a difference from something like the DOM inspector in Firefox is that this is entirely message-based. What we're doing is we're sending messages, and so it's not, I think at least with the, I think you can edit it in Firefox, I believe. I'm not really a web developer.
Probably come back.
OK. I guess I'll just wait for a minute. Did I step on something? OK, so it's on one of the screens. Should I just go on from there? OK, I can't really see it anymore, but we'll assume that it's working. All right, so for example, watch carefully. As I click on the select all line here, well, that's sending a message, happens to send an argument, which isn't very important, but it's selecting each of those graphics. So I am actually modifying the objects. I'm not just viewing them. And let's take that a little further. So first of all, you might have noticed, I mean, this is sort of information overload. You cannot deal with all of this at the same time. So there's this search field up at the top, which hopefully I can get to, good, where I can filter down and look at individual methods that might be more interesting to me. Now, I happen to know that those shape objects are actually of a class called a graphic, an SKT graphic. So I filtered down to only see messages that had the word graphic in the title. And when I click on this, I get back an array. I double-clicked on it so I could see it, so I could get a better view of it. And when I click on a single one of these, again, it's using the standard. There's a certain method that all Cocoa objects implement to print out descriptions of themselves. It's called description. So this is invoking the description method on this graphic view, SKT circle, apparently, that is describing it. So that's pretty cool. And we definitely can get a pretty good view of exactly what's going on, which is especially nice when things start going wrong, because you can start figuring out why. But let's just mess with this a little bit more. So say, for example, we wanted to do something having to do with the color. OK, well, we can send the fill color message, and we can see that the circle we're currently working with has some color. It's a calibrated color. This is also sort of interesting. So this is telling us that if we were viewing it on a monitor with a different calibration profile, it would still come out as an accurate color, hopefully. And if I want to say set fill color, now I can use the same FScript syntax that Philippe has already showed you to make it say orange. And it just turned orange back there. I don't know if you saw. OK, so all right, interesting. So one last thing that I'd like to do with this here is show how it integrates back with the inspector, with the interpreter. So that's nice, but now if I want to, but for some things it's easier to use a command line interface than it is to use this graphical tool. So what I can do is I can select this graphic view, click name. This is allowing me to give the object a name. So I'll call it graphic view. I would never use such long names in FScript if I weren't trying to demonstrate it for you guys, but I'll be nice. One-letter variable names are the order of the day when working with things that you immediately throw away. Here it is. There's the graphic view. It showed, because I gave it a name over here in the browser, they're basically working with the same namespace. So I'm finding it over here in the inspector as well. And this is good for sending. I'm going to preview a little bit some of the other interesting aspects of FScript that Philippe has not explained yet. He showed you the basic syntax. He has not showed you, however, that FScript is an array programming language. And I'm going to show off that a little bit. So if I get all of those graphics again, here I'm just sending the graphics message. That's not too special. I'll just name that. I can't help myself, so I'm now just going to call that GS. There's the graphics. And if I send the fill color message, I'm now sending the fill color message to the collection, and I get back the collection of colors. This is using the array programming aspects, which will be explained in a minute. But I wanted to do it for now because I'm going to demonstrate how clear and how easy it is to do something like, oops. I'll have to delete that because I don't know what's going on. To change the fill color of all of them at the same time. So what I'll do is I will set each one to be half opacity. And I will, because I want to make sure I spelled everything right, I'm going to use the completions that Philippe has put into FScript. There's only one completion for this, color with alpha component. I'll say 0.5. And what we should see is each of those shapes we have on the screen should now become half opaque, which it did. And see, that's not very much code. Normally, you'd have to write a couple of loops to get that kind of thing. Well, maybe just one loop. But anyway, that's the kind of thing we're gonna take a look at. But that's all I have in my first demo. So let's go back to the slides and let us sort of contemplate what we have seen, provided I can get this going again. OK, so what did we see? Well, first of all, we saw the object browser. OK, I want to emphasize one more point about the object browser that I have not discussed yet, which is that this is a really good way to get into FScript development, because you saw how little knowledge I actually had to have of the FScript language before this started becoming useful to me. All I had to do is point at things and click on them. If you're already a Mac OS X developer, I really don't know if you guys are or not. Maybe I should take a quick survey. How many of you actually do Cocoa development? OK, 3 for the camera. Oh, well. For you guys, you don't need to know a whole lot to start using this and to start it being really useful. And however, once you've used this browser, when you do need more power, it's all there, because you have a full language to use when that becomes a useful thing to do. So it's really good for exploration. It's really good to understand how your application works and how it is currently working. So it's extremely useful when something is going wrong to just find out what is the state of the object network. GDB is really good when you already know sort of where the problem might lie, and you can go into an individual method and see what's wrong. But often for our things, the individual methods may work pretty well. The problem is that somehow the entire object graph is connected in some fashion that you weren't thinking about and is causing problems. And FScript really excels at debugging that sort of problem, because you can just take a look at how everything's wired up, and you can take a look at the actual current state of things, and you discover, oh, yeah, I forgot to handle this case. This is not something that my code is capable of dealing with. Along that line, we have the idea of point-and-click debugging, which certainly occurs in other systems, but it does not otherwise occur in Cocoa. So in an application like Sketch, and hopefully your applications as well, are reasonably large. I mean, Sketch is not large compared to a real application. And there's a lot of code. And so often when you have a problem to solve, one of the first things you have to do is you have to go find the relevant code. And that is actually just busy work in a way. In FScript, you can just point at it. If it's on the screen, you can get and you can sort of go down the rabbit hole as far as you need to go to find the actual class that's relevant, which can really be very quick. And then, actually, maybe I'll say something about that. It becomes sort of interesting. You realize that you make many fewer assumptions about state if you're using something like this. I found that when I started using FScript a lot, I realized without even thinking about it, without FScript, I was doing things like assuming, oh, this is the case because I know how it was set up. I know that what I was trying to do back here was set things up in this way, so that's how they are. Well, with FScript, because you're not looking at the why, you're always looking at the actual current state of things, you won't fall into as many bad assumptions that way. And those bad assumptions can be exactly the times when you end up spending hours on some problem that was just dumb. All right, and the last thing that I'd like to go back and do another little demonstration for is the idea of experimentation. So this is a really good way to find out exactly how the frameworks work, and to figure out how to answer little questions you might have that will further your understanding of Cocoa and just of programming in general, hopefully. So let's go back to this demo. And now for the demonstration for this one, I'm going to use the other big, it's still running. Let me actually quit this. Set it back to English again. Luckily, I do actually speak French a little bit. And I want to show you the other biggest sample application we have, which is TextEdit, which those of you who are even Mac users will recognize as the standard little word processor that we have on the platform. But all of the sample code for TextEdit is in fact available. It's written by my boss, who is also the head of Cocoa development. And here it is. So this is what it looks like when it's running. You see it already has an FSA menu. That's because we've set it up so that, which is often what you'll do if you're actually working with your own application. We've told FScript Anywhere, every time this application shows up to the party, every time it gets launched, see this always checkbox? Always load FScript into it, which is typically what you want to do when you're debugging. OK, so why did I bring this up? Well, because I wanted to show you something which is sort of a little bit more advanced detail of Cocoa, which probably those of you who are not Cocoa programmers are not aware of, which has to do with the field editor. So the field editor is a concept that has to do with the editing of text. It turns out that editing text is a fairly complicated process, and there are quite a few objects involved with it. And in particular, there are more objects involved with editing text than there are with just displaying text. So there's an optimization that is made in Cocoa a long time ago, which is that these objects which display text are relatively dumb and relatively small compared with the object that I'm using that are in place when I'm actually editing. And the way this works is that there's actually a shared editing object that, per window basis that's used in all the places where text is edited. And that is called the field editor. And it's a different view. It actually draws right on top of the existing display text field, it's called, that's already there. So let's, and with FScript, we can sort of take that abstract knowledge and we can observe it. So right now I'm editing the text field that has 75 in it. If I poke at the one that says 30, you see the class is an text field. That is the relatively dumb object. However, if I poke at the one that I'm currently editing, I see I get a text view. This is the field editor. And there it is. And we are able, it is now real for us because we see it. If I send the delegate message to the text view, I get the field that underlies it. So if I were to click off, see that this field was at memory location 3B3160, just remember the end. If I go click on this now that I've switched to editing a different one, see that's the one I now get when I click directly there. Okay? So there's the field editor. All right, so first of all, we've been able to sort of make more concrete something that we already see in the documentation. But here's something that's not in the documentation, and a question that I had 9 months ago or something, okay? So the question is this: how about if we know that we use the field editor for an editable text field, we know that we don't use it when it's just displaying text, how about when you have just a selectable text field? Does that use the field editor or not? It seems more complicated, but it doesn't seem as complicated as full editing. So with FScript, we can quickly just get a good answer for that question. So unfortunately, we don't have any text fields here which are selectable and not editable. So the first thing we will do is make one. So let's go over here. I'll filter down to the word selectable. There it is. There's set selectable. I'll pass yes. And now if I go back over here and click, as we are changing the object model at runtime, it is now selectable. OK, great. So now let's click on it. So here is the I guess we don't really have a hypothesis, but what we're testing is when I click on this, I'm either going to get a text field or I'm going to get a text view, and which is it? Well, click, text view. It's using the field editor. So we just found something out. That is pretty much what I'd like to say about that. So hopefully it's interesting to you. Hopefully for those of you who are Cocoa developers, you'll see that it is really a different way of thinking about your objects that will really emphasize to you to what degree Cocoa really is a runtime system. And I just have one more slide that I'd like to do before I turn it back over to Philippe, and that is on the subject of encapsulation. You may have noticed here that FScript is letting you at a lot of stuff. It is a white box debugging technique and exploration technique. That is great when you're trying to debug problems, when you're trying to figure out what's going on. However, there are some issues with it that, as somebody who's actually in the Cocoa group, I would be remiss not to discuss. You are going to see all sorts of stuff that you're not supposed to use when you do this. You're seeing private methods. Objective-C, for those who are not aware, does not have a language-level concept of a private method. It treats developers with a lot of trust. There's pretty much nothing that you cannot do. Nothing is prohibited. What we do instead is that the way we make a method private is that we do not document it, and we don't put it in the headers. Okay? That doesn't mean it's not there. However, that also doesn't mean that you should use it. I mean, it's really important to respect the contracts that we set up, because otherwise we find that we cannot improve the frameworks, because we're being held to this sort of arbitrarily tight contract that we weren't even aware of. In fact, a lot of the way that I end up using FScript is that, hey, I try to improve something, suddenly this third-party application breaks. What am I going to do about it? I have to figure out what's going on. So please, it's a sophisticated tool, and you should all use it, but keep track of what you're doing. You really need to make a good, solid distinction between what you know. I want you all to understand everything. I mean, I know we don't document it, but there's no reason for you not to understand all of how Cocoa works. It will do nothing but make you a better developer. However, you can't rely on it. I mean, you need to really make a solid distinction between what you know and what any particular block of your code knows. Okay, well, this is the fundamental principle of encapsulation in the first place. So hopefully this is not news to you. I mean, you do this whenever you write any of your own code. I mean, when you write this class over here and this class over there, they're not supposed to have knowledge of each other's internals. So for some reason, people kind of like to treat the code that ships on the actual operating system a little bit differently. I think they think of it not changing. In fact, it changes quite a bit. It's just that we always try to maintain the public interfaces. So don't go under those public interfaces. Oh, OK, well, that's all I have to say. So I'm going to bring back Philippe to finish up the talk. And what he's going to speak about is some of what makes FScript unique, which is the way that it melds array-oriented programming with object-oriented programming. So, Philippe.
Thanks, Ken, for this great demo. So I'm going to quickly introduce you to this new programming model we have in FScript. So let's go. Message sending is a fundamental operation in object-oriented programming, okay? As it supports polymorphism and encapsulation. However, it remains a very fine-grained, low-level operation. In high-level programming models and languages, or yes, models, like array programming or relational algebra, complex programs are able to deal with entire sets of data at once and are expressed in a very compact manner without requiring the use of loops, tests, or navigation instruction in a data graph. In traditional object-oriented languages, the same program would often require tens or hundreds of lines of code to do the same thing. So the goal we have here with the FScript is to provide higher level capabilities for object manipulation. To illustrate the point during the rest of this talk, let's define a very simple object model for an airplane company. Okay, we have three classes: flight, airplane, pilots. An airplane and a pilot are associated with each flight. And we define three object collections. We have A that contains uppercase A that contains our airplane instances, F contains our flight instances, and P our pilot instances. Now, to give you an idea of what we want to achieve, here is an example of programming with FScript. So the goal here is to print the names of all the pilots ranked by salary in increasing order in charge of a flight on a B747 airplane. Here is the code in a typical object-oriented language, here in Java. And here is the code in FScript. So the point here is that it is shorter, easier to write, and to understand. Another example. We want to select the pilots who are in charge of at least one flight for each airplane in the fleet. Again, here is the code in a typical object-oriented languages, here in Objective-C. And here is the code with FScript. It's just one line and much easier. We'll see how it works. So how does it work? And what is array programming? So array programming has two key characteristics. First, operations that apply to single values can be applied with equal ease to entire sets of data. And second, a new set of operations provide powerful means of data manipulation. Let's take an example of array manipulation, a simple example. Well, just before that, the classic array programming language is APL, for which Ken Iverson got the Turing Award. And it's a language that is based on the mathematical notation, the possibility of manipulating vectors and matrices as a whole. So let's see how we had two arrays of numbers in APL. We just write it as in math. Same in FScript. Here we have two collections of number objects, and we return a new collection. In traditional object languages, dealing with collections of objects is more tedious. So integrating array programming into object-oriented programming presents several challenges. The goal here was to find a general solution requiring the minimum of modification of existing languages. And in addition, we didn't want to place any constraints on objects. So developers do not need to know in advance whether the objects will be used with this array technology. This model introduced a new concept for the manipulation of objects, and it's called message pattern. So first, what is an object-oriented program? We can see an object-oriented program as a specification of which messages are sent to which objects. In traditional object programming, the basic syntactic structure makes it possible to specify the sending of a single message to a single object. And so what we suggest is to adopt a new structure that allows for the specification of the sending of complex groups of messages to whole collections of objects. And this is this new structure that we call a message pattern. So FScript provides a notation that allows for specification of message patterns in an operational manner. This notation enables the expression of a wide range of patterns and has some interesting characteristics. For instance, the classic message sending notation is still supported. It just becomes naturally a particular case of message pattern. So let's see some example. In the first example here, we multiply each element of an array by 2 by sending this message to our array. This message pattern, sorry. And as you can see, in the second example, we multiply 2 arrays element-wise. As you can see, these message patterns, expressions, look like traditional messages sent, but they are not interpreted in the same way. What happens here is that they generate multi-messages sent automatically. So up until now, we have seen examples with arrays of numbers. The good news is that it works for any kind of objects. Here are some examples. In the first one, we ask each pilot object for its name using a message pattern. So we get back an array of names. In the second example, yeah?
The previous example, or even this example, what happens if the array understands the message times or names?
OK, so the question is what happens if the array understands the message that we want to send to each element, right? So in this case, the array will respond, OK? But there is a notation to express the fact that we want to send the message to each element. So there is a lightweight notation that takes place, in this case, inside the message expression itself, that lets you specify to which level you want to go and things like that. So in the second example, we ask for each flight for its departure date. We get back an array of dates. And message patterns have the same precedence level as conventional messages, and thus can be composed in a similar way. In this example, we determine for each flight whether its departure date is after the current date. OK? So in the end, we get a Boolean array. And as you will see, Boolean arrays are extremely useful in FScript and in array programming. So all the message patterns we have seen so far use an implicit notation. In some cases, we need to provide more information, as you just asked, to describe other kind of pattern. For instance, we may want to use message patterns on nested arrays at different levels, or we have various iteration forms, such as outer products, things like that. In this case, we use lightweight notation using the @ symbol to specify where the iteration have to take place. We'll not go into the detail right now. OK, the notion of message pattern alone is not sufficient to fully integrate array programming in object-oriented programming. Message pattern become really powerful when they are associated with specific array programming operations. There are a number of such operations in FScript. As example, I will show you 3 of them. So first, compression. Compression selects certain elements of an array and returns them in a new array. This operation requires 2 operands. First, the array from which we want to make a selection. And second, a Boolean array of the same size. An element is selected if the corresponding Boolean holds true. Okay? So in FScript, we have extended the at method, which is the indexing method, in order to perform compression when given an array of Boolean as arguments. So for instance, suppose that our array P contains 7 pilot objects that we see here. If we want to select elements at index 0, 1, and 4, we can apply compression as in this example, using this array of Boolean. And it will select only these pilots. OK? Now, OK, sorry. No. As you see, compression requires a Boolean array. But this array, as we have seen previously, are very easy to generate with message patterns. So, for instance, the following expression returns the pilots whose salary is greater than 3,000. And this expression returns the pilots whose salary is greater than 3,000 and whose age is equal to 40. OK? We use message pattern here. And here, it's compression. Another important operation in array programming is the possibility to index an array by a whole array of indices. This provides a very general way to designate elements of an array. And there are several methods in FScript that let you conveniently generate array of indices for various purposes, like selecting a particular region, sorting, and so on. OK. Let's keep this example of sorting and go to the end to show you a comparison between this model and classical iteration pattern in high-level programming language, in high-level object-oriented programming language. So we want to get the name of all pilots. In Smalltalk, the standard way to do that is to use a block, that is a lambda expression, and use the collect method. In Ruby, we do the same thing, just with another syntax. In Python, we will use probably this form, which is the list comprehension form. In C# 3, we'll use this new link system, which has a SQL-like syntax, and which uses lambda expression behind the scene. And OK, here is how we do in FScript. The big difference here is that here we are syncing and dealing with one object at a time, whereas here we are dealing with the whole collection at once. The last example, something a little bit more complex, get the names of the pilot whose salary is greater than 3,000. Again, in Smalltalk. Ruby, same thing. Python, still using list comprehension. And LINQ, and FScript. Okay, again, the difference is that in FScript, we try to free our mind from the one object at a time model. OK, that's all for today. So if you have any question, it will be a pleasure to answer. Yeah?
Can you say anything about the implementation? What, how fast is it? Someone to do something with what kind of garbage collection is it using?
Okay, the implementation of FScript in general, or the array stuff in particular?
Well, both.
Okay.
FScript in general.
So FScript is...
Repeat the question.
Yeah, so how fast is the implementation? This is the question. So FScript is implemented as an interpreter. However, all the objects that are used are Objective-C objects. So each time we send a message to an object, we are executing compiled code. So it's in general pretty fast. The array stuff is specifically optimized. That is, we can internally the arrays are using, when possible, primitive type to store their representation and to compute things. For instance, when you deal with arrays of numbers or arrays of Boolean, and you deal a lot with this programming model, it's optimized, so it's going at the same speed as native C arrays.
And maybe I can add a little bit. So if you're asking about garbage collection in particular, it's not garbage collected. It's using the same model that Objective-C uses, which is explicit reference counting. Though there are some conveniences to make that sufficiently easy that we actually call it semi-automatic reference counting. But what's going on in FScript is every time you name an object, it receives a retain message, which increases its reference count. And every time it falls out of scope, it receives a release message. So it's naive. And yeah, and if you're not being careful, that will cause cycles, and you'll also leak a lot. But often for the sorts of things we're doing, we don't really care, because we're just working at runtime, and we're just going to throw it away anyway. So
it just uses the standard macOS 10 memory management strategy. And if you use a new garbage collector,
yeah,
it will use the new garbage collector in macOS 10.
So Objective-C 2, which is shipping as part of the next operating system release, Leopard, is garbage collected, or optionally garbage collected. And Philippe will hopefully be able to improve FScript so that it also runs garbage collected under those circumstances. Also, I wanted to just maybe add a little bit when you were talking about the explicit array iteration syntax before. The use of that syntax is really a lot like use of parentheses. You can use it if you want. It's optional in cases where it's not ambiguous. So I think I probably tend to use it a little bit more than Philippe does, because similarly, I parenthesize almost everything all the time, just in general. And I also use the explicit notation, except in very simple cases. It's actually not implemented as an input manager. It used to be. That's not the case. In fact, you're like thinking of the distribution that's on my webpage, which is as the input manager, but that is not, in fact, how it's implemented now. It's been reabsorbed into the FScript distribution, and it uses mock inject, which is a way of dynamically injecting the process at runtime into an application, which is also sort of fishy, but it's. No, it's not using an input manager, and it does have some security stuff. In fact, one thing we didn't show is that you have to make the application set GID in order to have it be able to inject like this into the proc mod group, modify processes. Sorry.
Yes?
So if you send a message to an array, will it always send it sequentially depending on the sequence of the object in the array?
Yeah. So the semantic is defined like that.
Want to repeat the question?
Yeah, the question was, if you send a message to an array, in order to send the message to each element of the array, will the messages be sent sequentially, depending on the order of the array? And the answer is yes. It's intentional. It's intentional. Yeah. It's very useful for some of the array programming patterns that are used here, some of the techniques. It's useful to have this semantic. Yes, but it would be another model.
You could do that anyway. You just have to be. I think pretty much always want to be explicit about that anyway. I mean, or at least you'd have to have some way of knowing that the messages that you were dispatching were safe to parallelize. So it's never something that we could just do to everything, right? Make sense? So, so yeah, I mean, you'd want to be explicit about that anyway. And if you're being explicit, it's basically just sending a message. So yeah, you can implement it right in the same system.
They're getting ready to set up for another event in here after this.
Okay.
So we'll probably have to call it.
Okay. So thank you, everyone.